All right, so now let's take a look at the example on page 5 that we're asked to work. We're given two pieces of information here. We're told that the radius, always double check and make sure it's the radius and not the diameter being provided, otherwise you'd have to calculate the radius. The radius of 12 centimeters, and so now we know that this length right here is 12 centimeters. Right, and we're told that it's subtended, which is just fancy words for the portion. So subtended relates to the portion of the circle, and that means that our angle right here, obviously not represented in that way, but that would be our angle right here, is going to be 120 degrees. The issue we have, though, of course, is don't forget that our angle theta must be in radians in order to use this formula. So the first thing we're going to have to do is convert angle to radians. And the way that we're going to do that is use our converting factor, 120 degrees times pi radians over 180 degrees. And when we do that, we get 2 pi over 3 radians. So our angle now measured in radians, we can use the formula. So the second thing we're going to do is we're going to find the arc length. And the formula that we're given up above, S equals theta r. You can plug in our angle now in radians, 2 pi over 3 radians. And 12 centimeters, which is our radius, including units. And if you remember when we talked about the need for radians, one of the reasons was so that we didn't introduce units when we did quote math using angles. And radians is kind of the unit. It's really just the word to describe that we're using this unitless thing to talk about the angle. And so when we do this math, the radians are not included in the units, and we get 2 times 12, so 24 pi over 3. And that's in centimeters, and that simplifies down into 8 pi centimeters. So the length of the portion of the circle that we're talking about here is going to be 8 pi centimeters long.